Here is a thing that keeps happening. Someone demos an AI agent, and it is genuinely impressive. It books the flight, it files the ticket, it reads the spreadsheet, finds the error, and fixes it. Then the same agent goes into production, and within a week, it is doing something baffling. Ordering 400 units instead of 4, or confidently reporting that a task is finished when nothing happened at all. The demo was real, the failure is also real. And the gap between them is not a bug that somebody forgot to fix. It is structural. And once you see the structure, you cannot unsee it. Almost every agent you have ever used runs the same loop. It decides what to do, it acts, calls a tool, clicks a button, writes a file. Then it observes what came back, and that observation becomes part of the input for the next decision. Decide, act, observe. Around and around. That loop is the whole idea. It is what makes an agent rather than a chatbot. It is also, and this is the important part, a machine for turning one small mistake into a large one. Because every observation the agent makes is written by its own previous action. Now, I want to be fair here, because the honest version of this story is more interesting than the cynical one. A lot has genuinely improved. A synthesis published in July 2026 looked at 27 papers across 19 benchmarks, and it found substantial progress in 3 specific places: single-turn tool use, short-horizon web navigation, and narrowly scoped coding. On WebArena, success went from roughly 14% when the benchmark launched to 61.7% about 18 months later. That is not hype. That is a real curve going up. So why does it still fall over? Start with arithmetic. Suppose a single step succeeds 90% of the time. That sounds good. Now chain 20 of them. 9/10 multiplied by itself 20 times is about 12%. A 90% agent finishes a 20-step task roughly 1 time in 8. And that is the optimistic version, because it assumes every step is independent. They are not. The same synthesis found that failures compound nonlinearly with task length, worse than multiplication, because a mistake at step 3 does not just fail, it poisons the input to step 4. Make that concrete. Say you ask an agent to reconcile last month's invoices. Step 1, it lists the files. Fine. Step 2, it parses them. Fine. Step 3, one invoice has the date written day, month, year instead of month, day, year, and the agent parses it as a different month. No error, nothing crashes. The number is simply now in the wrong bucket. Step 4, it totals the buckets. Step 5, it compares the totals against the ledger and finds a discrepancy. And here is the part that matters. It does not conclude that step 3 was wrong. It concludes that the ledger is wrong, because the ledger is the thing that disagrees with the work it just did. Now it is confidently investigating the wrong problem, and every step from here is spent building a case for a conclusion that was already broken. The paper sorts the failures into 6 clusters, and they map cleanly onto the loop. The first is the simplest and the most common: tool invocation and parameter errors. The agent picks the right tool and fills it in wrong. A date in the wrong format. A unit it assumed. An identifier it invented because the field was required and it did not have one. The tool accepts it, tools usually do, and returns something perfectly well-formed and completely wrong. Second, planning and constraint satisfaction. Give an agent a goal with 3 constraints, and it will often satisfy 2 and quietly drop the 3rd. Not refuse it, drop it. Book the flight under budget, on the right date, to the wrong airport. The plan looks complete because every step in it succeeded. Nobody checked whether the plan was the right plan, and the agent has no separate faculty for that. The thing that makes the plan is the thing that made it. Third, And this one is the quiet killer. Long horizon degradation from context accumulation. Remember that the loop feeds every observation back in. 20 steps later, the context window is full of the agent's own history. Old results, dead ends, stale assumptions, a note from step 2 that is no longer true. The agent is now reasoning about a document it wrote itself, in which nothing is marked as expired. Performance does not fall off a cliff. It sags, gradually, in a way that is very hard to notice from inside. Fourth, multi-agent coordination. The intuitive fix for a struggling agent is more agents. A planner, a critic, a worker. Sometimes that helps. Often it produces a committee that agrees with itself. The critic reads output the planner wrote, in the planner's framing, and confirms it. You have not added an independent check. You have added another turn of the same loop, wearing a different hat. Fifth, safety and security failures under adversarial or underspecified conditions. Two different problems in one cluster. Adversarial is the one people talk about, a web page containing instructions the agent obediently follows. Underspecified is the one that actually bites. The task simply did not say what to do in this situation, and the agent, which is built to be helpful, does something anyway. It will almost never stop and ask. And sixth, the one that should worry you most, measurement validity. The benchmarks themselves. If a benchmark scores only the final answer, an agent that reached the right result through 3 wrong turns and a lucky guess scores identically to one that reasoned correctly. The synthesis makes the point directly. Strong performance on individual subtasks does not reliably translate into end-to-end success, which means the number on the leaderboard and the thing you care about are not the same number, and the gap between them is invisible in the score. The standard response to all of this is scaffolding, retries, validators, a verification pass, a supervisor agent. And some of it does work. But here is the finding that should change how you plan. Across the literature, additional scaffolding does not consistently improve reliability. Not never, inconsistently. Which is worse in a way, because it means you cannot know in advance whether the layer you are about to build will help, and you will only find out in production. It is worth asking why a competent person does not fail like this, because they are running a similar loop. 3 reasons, roughly. They replan, not just the next step, the whole approach when something feels wrong. They hold a sense of which of their own earlier conclusions are shaky, and they downgrade them without being told to. And they stop and ask, which is not a capability so much as a willingness to be briefly useless. None of those 3 are things a next token predictor gets for free, and 2 of them are actively trained out by rewarding helpful, confident, complete answers. So what do you actually do with this? Shorten the chains. Every step you remove is a multiplication you no longer pay. Check the plan, not just the steps, because a plan made and graded by the same model is not checked at all. And treat any long horizon benchmark number as an upper bound measured under generous conditions, not a promise. None of this says agents do not work. Single-turn tool use got genuinely good. It says the loop that makes them powerful is the same loop that makes them fragile, and you cannot keep one without the other.